Hi, today we're going to talk about exponents. Exponents are fun. So we're in section 1.7, pages 27 to 31. Exponential form is just a way to do a shortcut. We don't want to write 5 times 5 times 5 times 5 times 5. It's just an easier way to write 5 to the 5th power or whatever. So my first example here is write 3 times 3 times 3 in exponential form. The 3's are called the base, and there's actually, if there's no little exponent there, they're actually 1. So you have 3 as a base, and if you add the 3 up, 1, 1, 1, you're going to get 3 to the 3rd power. Okay, so that's how many 3's are there? There are 3 to the 3rd power. Write 5 times 5 times 5 times 5 times 5 times 5 in exponential form. So count out how many you have, 1, 2, 3, 4, 5, 6. So it's just 5 to the 6th power. Evaluate 3 squared. Okay, so now we're evaluating. 3 squared does not mean 3 times 2. It means 3 times 3. 3 times 3 equals 9. Evaluate 7 cubed. So you write 7 times 7 times 7, which equals 49, times 7, which equals 343. And the last one, evaluate negative 2 to the 3rd. Now you're going to have to use your negatives. What do you know about negatives in this problem? You have a negative times a negative, because you have 3, this tells you to write negative 2 3 times. A negative times a negative is a positive, but then you have a positive times a negative, so the answer is going to be negative. You've got to be really careful with these negatives. Anytime you have an odd amount of negatives, it's going to be negative. If you have an even amount of negatives, it's going to be positive. We have an odd amount of negatives, we have 3 negatives, so it's going to be negative. But the way to just figure that out is go, okay, negative times a negative is a positive, positive times a negative is a negative. 2 times 2 is 4, times 2 is 8. All right, so we're going to look at some properties. We're going to look at some little shortcuts. These are all properties of exponents. The first one is the multiplication property with like bases. So our base here is x, and our exponent is a. This is a variable, and this is another variable. They both stand for numbers. If I had x to the a times x to the b, this is only in the case of like bases. The two x's are like bases. So we keep the base and we just add the a plus b. What does that mean with numbers? If I had 2 to the 3rd times 2 to the 5, all you do to do this is keep the base, which is 2, and add your exponents. So I'm going to add 3 plus 5. And I get 2 to the 8. And if I wanted to figure out what 2 to the 8 was, I'd have to multiply 2 by itself times 8 times. I'm not going to do that right now. Division and property with like bases. X to the a over x to the b are divided by x to the b. When you have like bases and they both have exponents, you just subtract the numerator exponent. You do the numerator exponent minus the denominator exponent, which is x to the a. This should really be a little b. I don't know why I made the b so big. X to the a minus b. What does that mean with numbers? 2 to the 6 divided by 2 to the 4. You've got like bases. You've got 2 exponents. So all you do is take the numerator exponent and subtract the denominator one. 2 to the 6 over 2 to the 4 just equals 2 to the 6 minus 4, which equals 2 to the 2. Let me show you what that means if I did that out. If I wrote 2 times 2 times 2 times 2 times 2, that's 1, 2, 3, 4, 5, 6 over 2 times 4, 2 to the 4th power. So I have 4 on the bottom. If I just cross those out, because they're all 2 divided by 2 is 1, 2 divided by 2, those all cross out, and then all I'm left with is 2 to the 2nd power. That's what we got for an answer. This is a shortcut. That's why we're learning it. These are all shortcuts, so you can do it this way if you wanted to, but isn't that way a little quicker? Okay, the power property, x to the a in parentheses b. Now this is a little confusing sometimes because people sometimes mix this up. When you have an a and then it's in parentheses and then your b, you actually multiply those two. You don't add them. So when parentheses, you do a times b, you get x to the a times b. For example, if you had 3 squared times 6, all to the 6th power, that equals 3, then 6 times 2 is 12. Okay, if I did that out, it's going to be a lot, but watch if I do that out. 3 squared times 6. So 1, oops, that scared me. 2, 3, I'm going to go down here just because I don't have room. 4, 5, 6. Okay, that's 3 times 3 to the 6th power. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That equals 3 to the 12th power. That's why that works. Okay, the 0 property, if x doesn't equal 0, here's a huge thing for you. Okay, the base is x, the power is 0. Anything to the 0 power equals 1. Let me show you why. If you have x to the 5th over x to the 5th, anything over itself is going to equal 1. Okay, so I wrote that's 1, right? X to the 5th over x to the 5th. So if you went back up and did your division property where you had to subtract your two exponents, let's subtract our two exponents. 5 minus 5 minus 0, you get x to the 0. X to the 0 equals 1. That's because anything over itself equals 1. All right, we're going to go to the back wall and with some examples. Okay, I have like bases. I have two exponents here. I'm going to keep my base. What do I do with my exponents? I add them. 2 plus 4. So my answer here is 2 to the 6th power. Okay, how about here? I have like bases. I'm going to add my 3 exponents. 3 plus 5 plus 0. We know 3 to the 0 equals 1, so I could just say that's multiplied by 1, but I'm just showing it out for you. That's going to be 3 to the 8th power. I just add the 5 and the 3. Okay, now I have a division problem. 4 to the 4th divided by 4 squared. What do? You subtract. 4 to the 4 minus 2 equals 4 to the 2nd power. Okay? How about here? 8 to the 5th over 8 to the 3rd equals 8 to the 5 minus 3 equals 8 squared. And your last one, what do I do with this? I'm going to multiply those. 2 times 3 equals 8 to the 6th. Do you have to do all these all these ones? No, you can just come up with your, I know that 2 to the 2nd times 2 to the 4th is 2 to the 6th. I don't have to do all that out. Okay? All right, have fun. You're going to do all the exercises through exercise C on page 31 and 32. If it goes into 32, I'm not sure. All right, have a good day. Bye.